Pneumatic control valves are currently still in use at plants both in Japan and worldwide. This may be the result of their long history of automation and the technical challenge to create electric valve actuators with better control performance than pneumatic types. Recent major advances in magnetic materials have enabled the development of stepping motors that provide powerful operation just by applying a pulsed current. They have made ideal control performance available. Electric control valves have been created that provide smooth action with a resolution far above 1/1000th and no overshoot. Step-top is a series of stepping motor-driven electric valve actuators of M-System. Electric control valves with step-top do not need any of the air source equipment that is a mandatory requirement for pneumatic control valves, including compressors, air dryers, air lines, pressure-reducing valves, and filters. The control operation begins immediately just by connecting a power supply and applying a signal of 4 to 20 milliamps. As a result, some estimates show an equipment cost reduction to 1/5 the cost of pneumatic equipment, including the control valve cost. Energy consumption can also be reduced to 1/10 the amount used by pneumatic equipment. Making electric control valves explosion-proof is not easy, but possible. M-System has decided to take on an ambitious project for replacing pneumatic control valves with step-top controlled electric control valves in the world. A 1/1000th resolution step-top demo kit is available to demonstrate step-top's performance at a glance and show the innovation in electric control valve technology. Be sure to give the demo kit a try. M-System has two series of step-top electric actuators, the Compact Mini-Top series and the standard Servo-Top 2 series. Linear motion and rotary motion models are available in each series. Every model uses a stepping motor, achieving a good balance of high power and high resolution. Here is the structural image of the linear motion Mini-Top MSP5 used in the demo kit. The stepping motor is mounted in this area. A stepping motor has a structure composed of a permanent magnetic rotor surrounded by multiple electromagnets that make a stator. When a pulsed current is applied to the electromagnets, the rotor shaft rotates precisely at a fixed angle. The motor shaft of this Mini-Top makes one full rotation with every 24 pulses. The actuator's final output stem makes one complete travel with every 28,800 pulses. So these numbers correspond to a theoretical resolution of 1/28,800th per pulse. A stepping motor's rotary motion is converted to linear motion via reduction gear mechanism by means of a screw nut composed of a screw shaft and a nut. A linear potentiometer is connected directly to the output stem, and the stem's position is fed back to the control circuit. Now let's use the demo kit to see the actual operation. This area is the Mini-Top. The output stem's operation is shown on the dial gauge indicator. This is the input adjuster used to set the position. The 4-digit digital panel meters display the position control input and the position output. This is a function block diagram of the demo kit. The position set by the input adjuster is converted by the potentiometer transmitter and provided to the motor control logic circuit. At the same time, it is displayed in the digital panel meter. The position detected by the linear potentiometer is converted to a digital signal by a 12-bit ADC and input as a feedback value to the motor control logic circuit. At the same time, it is displayed in the digital panel meter. The motor control logic circuit uses a predictive control algorithm to digitally control the stepping motor so that the set value matches the feedback value. As a result, it can attain a position resolution of over 1/1000th. When the set value is changed, the position follows immediately to match it with no overshoot. Now let's turn the input adjuster. Notice the values in the position control input meter and position output meter. There's only a 1-bit difference in the smallest digit. The digital panel meters have a span of 1 to 5 volts, which means this difference is only 1/4000th. Now let's check these signals on the trend graph of M-System's tablet recorder. This is a next-generation type recorder that can display a trend chart on a tablet device. When the 1 to 5 volt position control input signal and position output signal are loaded into the tablet recorder, pen traces appear in the trend graph. Now let's turn the input adjuster slowly. The change in the position control input signal is shown by the blue pen and the position output signal by the red pen. You can see that the red pen tracks the movement of the blue pen without error. That means the actuator moves smoothly with no overshoot. You can see that even if the input signal is changed quickly, the position output signal still follows with no overshoot. Now let's apply force to the output stem. There's nearly no movement in the dial gauge indicator and graph. So you can see that even when using as a control valve, there is no effect of the reaction force of fluid. So we've seen that step-top electric actuators have the following features. Resolution far above 1/1000th. Control performance with no overshoot and nearly no effect of the reaction force of fluid. These outstanding benefits are what makes step-top electric actuators superior to pneumatic types. Step-top electric actuators are already in use at many sites for process automation, factory automation, and building automation. Their use is also expanding into equipment industry areas such as turbo compressors, chillers, and food processing machinery. The era of electric control valves is here. Step-top should be useful for a wide range of applications requiring precision settings for user plants and equipment. Be sure to look into the Step-top series. M-System can provide assistance with your inquiries. For more information about the demo kit and tablet recorder shown in this video, feel free to contact M-System's Customer Center. Thank you very much.